Hey everybody, welcome to topic number 4, divisibility and prime factorization. So what is so-called a divisibility is basically saying that if you have a number, is that number divisible by 2, by 3, by 4, by 5, by 6, by 9, by 10. So these rules right here kind of tells us, give us a guide, quickly to figure out whether the number I have is it divisible by 2, 3, 4, 5, 6, 9 and 10. Okay, so it kind of help us a little bit when we head into talking about fractions, especially multiply and divide fractions. So here's the rules. Okay, divisibility by 2. A number is divisible by 2 if the last digit, which is in the ones position, right, digit of a whole number is 0, 2, 4, 6, or 8. Okay, so we look at the ones position. So if that number is 2, 0, 2, 4, 6, or 8, then 2, then this number is divisible by 2. What that means is 2 can actually go into it. A number is divisible by 3 if the sum of the digits of a whole number is divisible by 3. So what that means is divisibility by 3 says, here's my number 207. The sum of the digit, that means I'm going to add all three numbers together, which give me a 9. So 9 is divisible by 3. So that means 3 can actually go into 207. Okay, that's the way. So these are kind of rules that kind of help us to recognize some of these numbers. What number I can use to go into to divide these number with. Divisibility by 4 is saying if the last two digits of a whole number, okay, form a number that is divisible by 4. So divisibility by 4 is looking at the last two numbers. So the last number is 52, right? So can 4 go into 52? Let's try it. 4 go into 5 one time. 1, bring down the 2. 4 go into 12 three times. So 4 does go into the last two digits. So that means 4 can go into 152. Okay. Now, be careful. If the last two digit here is 0, that's referring to 100. So 4 can actually go into 100. Just a quick note. Divisibility divisibility by 5, most of us know that if the ones digit is either going to be 0 or 5, that means 5 can go into that number. All right, so of course 5 can go to 710. A number is divisible by 6 if a whole number is divisible by both 2 and 3. Okay, so let's check the divisibility by 2 first. Divisibility by 2 says the last digit, the ones position, got to be 0, 2, 4, 6, or 8, which is what we got. Divisibility by 3 says I need to add up all the digits, see if 3 can go into it. So 4 plus 4 plus 2 plus 2. So that will actually be 12. So 3 can go into 12. 3 can, so that means 4422 is divisible by 3 as well. So that means this number is going to be divisible by 6. All right. Divisibility by 3 and 9 is similar. Divisibility by 9 says if the sum of the digit of a whole number is divisible by 9. So if I add up the digits, 4 plus 5 plus 2 plus 7, this is going to be 9 plus 9, which is 18. 9 can go into 18. 9 can go into this 4,527. All right, divisibility by 10, most of us know that, means 10 can only go into numbers that ends in 0. Okay, so with all that in mind, we'll try some example here in a little bit, but let's take a look at something called prime factorization. Okay, prime numbers. Prime numbers are referring to numbers that only have exactly two different factors, one in itself. Has exactly two different factors, one in itself. So what that mean is, okay, what that mean, two different factors, one in itself. So what that mean is, one is not a prime number because one is actually only one times one. Okay, one is only one times one. It's not two different factors. Okay, so what's considered as a prime numbers are two factors, one and itself. So such as 2, 3, 5, 7, 11. Okay, these are something I list these from. These are the prime numbers within the number 0 through 30, or 2 to 30. All these are the prime numbers. The one I highlighted here are the popular ones that we normally use. Okay, so composite numbers are numbers that have factors other than one in itself. Okay, so all the other numbers are considered as composite. Here are some of your popular primes. Okay, so all the whole numbers we have is either made out of prime or composite. Okay, and we know it's a so we know it's a composite number because that number has more than has more than one set of factors. All right. So, for example, find all the factors of the following numbers. Find all the factors. Okay. These are not prime factors. These are all the factors. So the way we do this is start with 1. Okay. 10. 10 is going to be 1 times 10. All right. So this is where divisibility comes in. Can 2 go into 10? Sure, because 10 ends in 0. So I know 2 will go into 10 5 times. Can 3 go into 10? No, because 1 plus 0 is only 1. 3 cannot go into 1, so 3 cannot go into 10. All right. 4. Nope. 5. Yes. 5 times 2 is 10. So since I already wrote 5 already, then that's it. So all the factors, okay, all the factors makes 10 is going to be 1, 2, 5, and 10. Okay. 60. Let's try it. Find all the factors 60. Started with 1. 1 times 60. All right, 2 can go into 60 because this 60 ends in 0 30 times. 3 can go into 60 because 3 can go into 6, right? 6 plus 0 is 6. It's 3 times 20. 4. Can 4 go into 60? I don't know because 60 is only a two-digit number, so let's give it a try. 4 going to 6 one times, right? Subtract, so it'll be 2. Print on the 0. 4 going to 25 times. So 4 times 15 will be 60. 5. I know 5 can go into 60 because this number ends in 0. So that would be 5 times 12. So I know 6 definitely can go into 60 10 times. 7 cannot. 8 cannot. 8 times no number is 60. 9 cannot. Okay, because 9 times 6 is 54. 9 times 7 is 63, so it's already over. 10. Oh, I already got 10, right? 10 times 6 is 60, so that's it. Okay, I don't have to say 10, I don't have to write 10 times 6 because I'm repeating myself. So all the factors. So that will be 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. All the other factors. So, all these are the factors 60. So what I mean is every one of these numbers can go into 60. That's just another way of saying it. So that's 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. That's how we write the answer. All right, 105. I don't know 105 very well, so I'm going to start with 1. I know 1 times 105. 2 cannot go into 105 because the last digit is 5. 3. Well, 1 plus 0 plus 5 is 3. Excuse me, is 6. 3 can go into 6. That means 3 can go into this number. I don't know how many times, so I'm going to give a try. 3 going to 105. 3 going to 10 about 3 times. That's 9. 3 going to 15 5 times. So 3 times 35 is 105. 4. 4 is looking the last two digit. No, 4 cannot go into 5. 5 can, right? 5 go into 105 about 21 times. 6. 6 can because 1 plus 0 plus 6 is 6. Oh, 6 is, I'm sorry. Sorry about that. 6 will be the divisibility by 6 says it had to be 2 and 3. So since I don't have any 2 here, since 2 cannot go into it, that means 6 cannot. All right. 7. I don't know about 7. I know 7 times 5 is 35. Ends with the 5, right? 105 ends with the 5. So I'm going to give it a try. 7 go into 10 one time. So that's 3. Bring on the 5. Oh, okay. See, 35. 7 go into 35 5 times. So that means 7 times 15 will work. All right. 8. 8 times no number where the answer ends with a 5. So I don't have to even try that. 9. 1 plus 5 is only 6. 9 cannot go into 6. 9 cannot go into this number. 10 cannot work. 10 cannot work because 10 can only go in the number ends in 0. All right, 11. I don't think 11 will work because 11 have to go into 105 at a time. 12 cannot work. 13. I'll try 13 because 3 times 5 ends with a 5, right? So I'm going to try it. So when I'm trying it, I'm basically just looking at 3 times 5, which I know this is only going to be 75. So no, it's not going to work. 14. 14, no. Because 4 times nobody, 4 times no number ends with the 5. 15, I already got 15. So that's it. And that's how we actually run through all the numbers until we repeat ourselves. So all the factors makes up 105 will be 1, 3, 5, 7, 15, 21, 35, and 105. All right. So this is how. So when we find all the factors of a number, we can use the divisibility rule to kind of help us a little bit. All right. Now these are different type of problem. These are called finding the prime factorization of a number. Okay. That means I'm only want to use prime numbers only. So let's scroll back up and look at our popular prime numbers. Okay, the one I highlighted. And a lot of these kind of repeat, right? Divisibility by 2, 3, and 5. So you kind of know that. All right. So the way I'm doing it, rather than write as like a tree method, I just put the numbers I have inside this upside down division. And on the outside, I find me a prime number that can go into 10. So I know 2 can go into 10, 5 can go into 10. So don't matter which one you use, okay? Either one, you will still end up with the same answer. So I'm going to use 2 first. 2 go into 10 5 times. So let's look at this 5. 5 is a prime number. Only 5 can go into 5 one time. When the bottom is 1, that's how you know this problem ends. So the prime numbers that makes up 10 is going to be right here on the side. So 10 is basically made out of prime number 2 and 5. Okay, those only two prime numbers. So y'all see the difference between using prime factorization versus finding all the factors of a 0. Okay, it's a big difference. Here we just want prime numbers that multiply together equal to 60. So I'm gonna try to again put the 60 inside this upside down division. So on the outside, I will find me a prime number that can go into 60. So I can use what? I can use 2, I can use 3, I can use 5. Can I use 10? Can I use 10? No, because 10 is not a what? Prime numbers. Okay, so you can use 10 if you want to, but knowing that 10 is actually also 2 times 5. Okay, when you write out the answers, that will be okay. But here I'm just going to use prime numbers only. So I'm going to start with 5. I know if I go into 6 one times, that will be subtract, that will be 1, bring down the 10. So if I go into 10 two times, all right, I'm going to use 3 here. 3 go into 12, right? I'm not looking at 60 anymore, I'm looking at the 12. 4 times. And 4, only prime number can go into 4 is 2. 2 go into 4 two times. And 2, since 2 is a prime number, only 2 go into 2 one time. Okay, when I see 1, I know my problem ended. So prime number that makes up 60 is going to be 2 times 2. Or I can say 2 squared times 3 times 5. Okay, since we already talked about exponents, you can write it as 2 squared times 3 times 5 if you want to. All right, 105. Let's give it a try. All right, the only prime number I can think of right now is 3 or 5. Right, because remember 1 plus 0 plus 5 is 6. 3 can go into 6. So I'm going to use 5. 5 going to 105 is 21 times. All right, to break down 21, I can use 3 or I can use 7. I'm going to use 7. 7 going to 21 3 times. 3 is a prime number, so only 3 can go into 3 one time. Okay, so that's how I end. When I see the 1 down here, that's it. All right, so the prime numbers makes a 105. Oops, sorry. The prime numbers that makes a 105 is going to be 3 times 7. Oh, it's 3 times 5 times 7. Okay, so just real quick, talking about divisibility rules and what we so called the prime factorization. These, so these are called the prime factorization. The last 3 problems we did. All right, that will conclude this video. Thank you for watching.